What you are looking at and listening to is the sound of an erupting lava dome at Guatemala's Santa Maria volcano. Under no circumstances should you ever get this close to a lava dome, as at any moment a portion of it could collapse or a large explosion could occur without warning, incinerating areas up to several kilometers away via pyroclastic flows. The Santa Maria volcano produced either the second or third largest explosive eruption of the 20th century in 1902, depending on the source referenced, completely devastating the region, removing a large chunk of the stratovolcano's main cone and causing ash to fall as far away as San Francisco. And this eruption occurred after the volcano had been dormant for a whopping 20,000 years. After a decade of weak phreatic eruptions from 1903 to 1913, a viscous lava dome began growing in 1922. Known as Santiaguito, this lava dome complex has been growing ever since, continuously erupting for 102 years straight and counting. Yet you might be surprised to learn that despite the complete lack of any pauses at this growing lava dome, the lava it is erupting today is not the same lava that it erupted a century ago. They are quite compositionally different, creating a fascinating story on how and why this composition change occurred. This change in composition has caused the associated hazards TES diagram and explosivity of the volcano to change over time, which is why it is important to understand. Before I explain what I mean, I want to briefly help everyone understand the TAS diagram, or total alkali silica diagram, which is what us scientists use to plot the composition of erupted material from a volcano. Compositions can tell us not only about why and how a volcano formed, but also the nature of the hazards it is likely to produce. Thus, I have labeled a Holocene active volcano that typically erupts a lava composition characteristic of each of these categories. In the case of the now more than century-old Santiaguito lava dome complex, when it first began to grow, it erupted distinctively Decide lava, which had a viscosity 30 million times higher than that of water and a temperature of approximately 870 degrees Celsius. However, today, what erupts from the Santiaguito dome is not dacite, but instead andesite. This andesite has a viscosity 6 times lower and erupts at a temperature of 940 degrees Celsius. This composition change has been constant in between these two time frames, as the lavas that erupted became less alkali-rich, less silica-rich, and higher temperature over time. Largely due to this fact, primarily the lower viscosity over time, more gas has been able to escape instead of becoming trapped underneath the lava, meaning that eruptions as a whole have gotten ever so slightly less explosive as the years progress. At the same time, the lava domes which have formed have gotten less steep over time,